Tinkercad assignment. So if you'll just follow along right now, you don't need what's on your screen. If you could just look up here, that'd be awesome. So we're going to talk about 5 different types of solar systems. And I'd love it if you particularly paid attention to the one that's most important is number 3 in the middle. So we're going to talk about from easiest or simplest to more complicated. The most simple type of solar system is what we did that first day when I gave you the panel, the little panel and the fan. It's basically a panel and a load. So direct to load. When the sun is shining, the load runs. Often it's a fan or a water pump or something. It's the most simple type of system. All right. The second type has a battery added. So you have a panel, a battery, and a load. An example of this would be like path lights that you have in your garden or that you've seen that turn on when the sun goes down. They have a little bit of extra electronics, but for the most part, it's a battery. When the sun's out, the battery's getting charged. When the sun stops going out, a little switch turns and starts turning on the light or whatever it is. So, but still, it's mostly just a panel, a battery, and a light or a load of some kind. The third kind is the type that we're going to be making. In this class, we're going to design them. It's a panel, a battery, and a load, but also a charge controller. That's like the brains of this thing. A charge controller makes sure the battery doesn't get overcharged and make sure the battery doesn't get over drained, because it can hurt some batteries to get completely drained. So a charge controller is basically responsible. It's like a traffic conductor. It's making everything coordinate right. So I've got a diagram of this. The charge controller is at the top, and each separate component connects to the charge controller in the right places. So Josh, I can't see your eyes, so I don't think you can see what I'm doing up here. It'd be great if you could look up here. Thanks. Everybody, you shouldn't be doing anything on the computer right now. You should just be looking up here. So the panel connects to the charge controller, the battery connects to the charge controller, and so on. Charge controller is the boss, coordinator. And this is the type of system that we literally will be building in our solar suitcases. Everyone's going to have a chance to assemble one of these. We're doing that starting next week. So the fourth type is all that other stuff: battery, panel, load, charge controller, plus an inverter. An inverter is a device that changes direct current into alternating current. Can I remind you all to put your phones away and take out your earbuds? Because we're in school and earbuds mean you're using your phone, and we're not using our phones. So thanks. Inverters come with a watt rating. You have, I went on Amazon and looked up, or I Googled inverters, and there's tiny ones you can have like for your cars. You could plug in a computer or something you want to plug in. But they have bigger ones for like boats and RVs or, emergency power. You could spend a lot of money on inverters, but we're not using them here in general. They could play a role in your design, but the last type of system is a grid that I'm going to talk about is a grid intertie system. And I'm not telling you these are the only types of systems in the world, but these are the kinds that we're talking about. A grid intertie has solar panels and then a big old inverter, and it changes all that solar power into AC current, which is what normally flows through our walls. And then it plugs it back into the house and the grid, the power grid. So, and there's no batteries. This is what our school solar system is. You look out the window and you see all the panels. We don't have batteries on campus. Our panels are just putting the power back into the grid, into the power grid. So the benefit of this kind of system is you don't have batteries. Batteries are expensive. Batteries wear out over time, and I can't imagine how big the batteries would have to be if we were going to try to run this whole school off batteries. So, um, but we instead of that, we have these. We use the grid as a battery in a way. I have a solar system on my roof at home, and I have this kind of system. I don't have any batteries on my solar system. When the PG&E shuts off the power, I even though I've got panels on my roof, I don't get the electricity. And while that seems stupid on the upside, I didn't have to pay another $10,000 for batteries or something. I just have the solar system that lowers my utility bill. So, um, all right. So our next steps for the solar project, I'm going to show you before I assign it to you, um, uh, is to identify what things you might want to power with an emergency solar kit if you were going to make one for your personal life. And I've got a spreadsheet that you'll have a copy of it in a second. I think I can make that go away. What I'm asking you to do, and all the instructions are in this document, the text is right here. But I give you space for 5 things. I'm asking you to give me four or 5 devices that you might want to power with an emergency power kit. And I'm gonna I'll show you what I'm asking you to do. So like I would like to be able to power my telephone in case of emergency. So I'm gonna write iPhone charger. And then you have to literally go to Google and figure out how many watts approximately each device you put here uses. So I'll show you like how many watts does my iPhone charger use. And for fast charging, iPhone 12 and later models require 20 watts. So going back to my spreadsheet, I'm going to write 20. You can just write 20. You don't have to say 20 watts. And then I'm asking you, I say in my instructions down here, if any of your items use more than 100 watts, I want you to put a note over here saying maybe it's too big, because there's some limits to what we're willing to do. And that's you may have noticed I said my Google remembered yesterday. How many watts does my refrigerator use? I was using that as an example. Home refrigerator uses from 350 to 780 watts. I mean, that's so specific. I think I would say refrigerator, and I'm going to go ahead on the high side, 800, and I'm going to say maybe too big. I'm not saying don't put something on there that you want to theoretically see if you could power, but I'd like you to note if it's more than 100 watts, just say maybe too big or question mark too big. And so pretty simple task today. Just each of you are on the Google Classroom will have your own copy of this document, and I want you to think of 4 things you'd like to power, 4 or 5 that you might like to power with an emergency power solar suitcase if you were going to be making one. You are going to design one, so I'd like everyone to have different answers. Don't just do the same thing as your neighbor. I mean, you might have shared devices. You can't. It's not like just because I chose iPhone charger, I'm not saying you can't have iPhone charger, but you want to keep it in the realm of things that are realistic. So watch this. How many watts does this is going to be fun, hairdryer use? 8 to 1800. So yeah, way over the top in terms of so even if you think, yeah, power's out, I really want my toaster to work. Toasters use 1200 watts. That's like five times bigger than what I'm allowing for our kit. So I think I'll stop